honestly. I love open source. Virtually everything I do is open source focused in some way, so that's a lot of fun. Currently, I'm employed at Calyptic Security as a software engineer, and we use OpenBSD on hardware firewall appliances that we sell to managed service providers. So, yeah, that's fun. So, OpenBSD is a Unix variant from. It has straight Unix roots, so it was originally forked from NetBSD in 1995. It's unique in that the developers have a very straightforward approach to writing code. So they prefer small code that's easy to understand and easy to follow, compared to these giant projects. There's a few, like if you look at like implementations of a program like ls, which is a pretty straightforward, it lists directories. The OpenBSD version is, I forget how many lines, but it's a trivial amount of code. And then you look at like the GNU equivalent and it's thousands, and you're just like, what? I don't know why this is even a thing. So, strong focus on security, strong focus on keeping things simple. It's also not a Linux distribution. So here's a...
Hey, sorry to interrupt. You guys will be the last ones here tonight, probably. Someone know how to lock the gate?
I think so, yeah.
It's just a padlock, right? So if you just swing it closed, all the other guys that are usually here later are going to be out soon.
Okay.
So
All right.
if you have any questions.
Yeah, and I'll lock the front door too?
Anyone else coming in? Because I'll just lock the front door. You guys can go out.
We might. Sometimes we have some stragglers.
Do you know how to do that with the little Allen key?
Yeah, figured it out.
Yeah. Thanks.
Cool.
Okay.
Thanks, Ryan.
Appreciate you guys. Sorry to interrupt.
Yeah.
So here's kind of a breakdown. So here's like the original Unix, and OpenBSD kind of comes down through here and eventually ends up here. It's hard to see, but so it starts with PDP-7 and then Unix 5.6. That becomes BSD 4.3, then NetBSD and OpenBSD.
What's PDP?
PDP is the
digital equipment.
Yeah, like the very, very first computers, like punch card kind of.
Mainframes.
Yeah, like Unix.
Who made PDP?
Oh, I think it
was it digital.
I think it was digital. We'd have to look. It was either digital or maybe IBM. I think IBM had a different one. Yeah, I can't remember.
I wouldn't bet on
it. You could also be not Bell Labs. Yeah, it could have been Bell Labs. I don't know. I can't remember. Anyway, a few things that make it unique. It's self-contained, and that's kind of a strange term. So like in the Linux world, you've got different pieces. There's like the kernel, which is developed by Linus Torvalds and that whole group of people. And then you've got like the GNU stack, which is the GNU people. So there's these different entities working loosely in connection with each other, but not cohesive. But on the BSDs, that's different. So everything is done in one set. So your compiler is right there, your libc is right there, your kernel, it's all in-house. So everything you need to build it is right there too. So it's self-contained in that sense. OpenBSD's approach to security is fairly unique. A lot of security features that you get in operating systems are optional or off by default, which OpenBSD kind of sees as not really security features because you're not going to turn them on, especially if they make things hard or slow things down. So OpenBSD often opts for enabling them by default, which can sometimes cause problems. We had an issue at work where when the Spectre meltdown stuff happened, early on, Theo Durad, who's the lead OpenBSD guy, he thought, okay, this is really bad. we need to get ahead of this by disabling symmetric multiprocessing, right? And so that became the default on OpenBSD, and it had a slowdown. It impacted a bunch of stuff. Not as much as you would think, but for work specifically, like boot time was majorly impacted. So we saw like a 20% increase in boot time on devices. So, but fortunately there was a toggle for that one. So what we did was while the machine was booting, we disabled it, and then once it was up, we turned it back on, or disabled it. Disabled the turning on of it. Yeah. So it's extremely capable. Out of the gate, it has a ton of programs while still being incredibly small. So you can use it for a lot of things. There's a built-in web server, a bunch of other stuff like that. And it has a very good track record. Only 2 remote pulls in a very, very long time. You look at the dates on the CVEs in 2002 and 2007. So few and far between. So some of the unique security features that it brings to the table. This is not exhaustive. There is a shitload of them, but these are kind of my favorite. Specifically, the top 2, pledge and unveil. So pledge is a function that you can call within a program, and it will tell OpenBSD, hey, I'm only going to use these system calls, and then from that point on, it can't make any other system calls. Unveil is the same thing, but for file system views. So if you only need access to /temp or something like that, you can set that in the program's code, and it won't ever be able to see anything else. Those are very advantageous if your program goes rogue. And someone's doing some ROP kind of stuff or something like that, you're going to be able to curb what they can do pretty quickly because they can't access file systems or other things like that. So then other things like write or execute. So on some systems and some, it's less common these days, but you would have memory that was write and executable at the same time, and there's danger in that because if you can execute it and you can write to it, you might do bad things. So address space layout randomization, Carl, which is pretty unique. It's called kernel address randomized linking. So every boot, the kernel rebuilds itself from a set of object files that exist on disk. And so the layout of the functions inside of the kernel are all randomized. So the next time the machine boots, that'll happen again, and it all gets randomized. So every boot is a unique kernel. Then recently, IBT and BTI features were added, and those are processor specific, so they're only available on AMD 64 and ARM64 machines. And those I don't know too much about those, but they're related to the Spectre and Meltdown stuff. So they kind of help mitigate those kind of vulnerabilities. And then similar to Carl, there's application layer relinking. So programs like SSHD and like the SSH suite of things all get relinked on boot. And libc, which is used in everything. So that's pretty cool. So here's an example of using pledge in a program. So this would just limit whatever program was running to standard in, standard out kind of operations, and then rpath, which means that it can read path information and path struct info from like system call. So pretty minimal set of things. It could be, you could limit a program to no system calls, and then if it ever tries to do anything, it gets killed. So pledge, when a program violates the pledges that you start out with, it gets beat down. The kernel just pulls the rug out from under it. And then just kind of like how pledge is used in the various programs in the base system. So I forget the exact number, but like 80% around of the programs inside of OpenBSD itself. So like your LS, your SCP, your SSH kind of tools, stuff like that. They all have pledge built in, and the way they do it is they start out with a broad set of pledges. So they'll say, here we need standard out, yada yada yada. There's a whole laundry list of them that I didn't include in the slides because it's way big. But you can ratchet down. So the program executes and you don't need access to do this kind of stuff anymore. You can say, okay, get rid of those pledges and just keep tightening things up. So that's pretty cool. Here's an example of using unveil. So this program would only be able to see things in /dev, and it would only be able to read write to them. So you could do, instead of RW, you could just do R, or C for create, or X for execute. So you could have, in theory, you could have it so that it could only execute things and not know what was in there and not be able to read anything. And here we're calling it twice. The first call says, hey, here's what I need to see, and the second call locks everything in place so you can't change it. This is kind of an unusual convention. Normally you would call pledge after this and say you don't need the unveil system call, and then it would pull it right up from there.
So that's a C program, right?
Mm-hmm. Yeah.
So is unveil expecting the programs to provide this in the program itself?
So ideally, no, but the case is made for being able to do it dynamically, or more dynamically. So like there's a number of programs like Chrome and Firefox, which are on OpenBSD. They're both pledged and unveiled. So in that one, unveil causes a lot of problems for end users because by default, all the main program can see is your downloads directory. So if you ever want to upload something that's not in there or have it access other files, you need to open that up.
So why not do like a bash file with your unveils and your pledges before running it?
So the way it works on those specific examples is there's a etc Chrome and an etc Firefox, and inside there is a .unveil and .pledge files that contain string versions of this. So you could go in and you can add whatever it is.
Okay.
I can't remember the format. I think it's just tab delineated.
Gotcha. So this would be a more unusual case of using
having it so that you can modify it outside of the compiled binary is typically frowned against. Just because the whole idea behind these things is they're put in place in the programs in a position where the developer knows that, okay, this, we're not going to need XYZ anymore, so we can chunk all that off. So, ideally they're set in code and they're not to be meddled with further down the line.
Gotcha.
So it's almost like you're expecting remote execution polls later on,
Right.
Pre-patching.
Yep. It's kind of that layered approach, yeah. So when a program tries to access a directory that is outside of the unveils, it'll get a no such file directory error. So it just doesn't see anything. The kernel doesn't expose it to it. So here's the thing about Firefox and Chrome. There's quite a few tools. I maintain a library for Go that exposes pledge and unveil. At one point I had one for Node.js, but there's tons of them. There's one for, I think someone made one for Bash even. But it gets tricky if you're using like an interpreted language and you call pledges, then that's it for the entire program. That execution can't do anything else outside of those sets. So it doesn't make a whole lot of sense in the context of interpreted languages. So yeah. So like in Firefox, for example, at one point, it's not this way anymore, but I'm going to use it as an example because it's convenient. At one point, the GPU, or the rendering process, not GPU process, was restricted to just standard in, standard out. So the rendering was very, very tightly locked down. It's since either been removed or changed. I can't remember. But I looked for the file and it wasn't there anymore. So not only do you have a bunch of security related things, but OpenBSD is extremely capable out of the gate. We've got built-in web server, border gateway protocol daemon if that's your jam. It's got a built-in hypervisor, built-in WireGuard, Acme client for doing Let's Encrypt TLS kind of certs. There's so much stuff. OpenSSH. OpenSSH is developed on OpenBSD. So if you've ever used OpenSSH on a Cisco router or on Microsoft now or anywhere, you have OpenBSD to thank for that.
Right, that's a pretty big deal, right? Because most people usually assume that OpenSSH came from the Linux world,
right.
But it wasn't the Linux world; it was the OpenBSD world that it came from.
Yep.
So is it OpenTSL or something like that? There was another one that came from
LibreSSL.
Oh yes,
Fork of OpenSSL. There's a laundry list. I don't think I included it.
Oh, I didn't know HTTPD was OpenBSD.
Well, so that name's a little bit overloaded. There's Apache HTTPD, which used to be included in OpenBSD source tree, but was later removed in favor of Nginx, which was then later removed in favor of HTTPD, the OpenBSD native web server, which is OpenBSD specific.
Okay, and that's what I'm familiar with is the Nginx version. Okay.
Yeah. So another thing you might not have known is that the C library on your phone has OpenBSD code in it.
Which C libc?
Mm-hmm.
Okay.
Yeah, on Android devices.
Wow.
So it's all over the place. Oh, at one point, OpenSSH, or not OpenSSH, sudo was also upstream in OpenBSD. That's since been removed in favor of a program called doas, which is much simpler. But Todd Miller, the guy that does sudo, is still an OpenBSD developer.
So who's doing the upstream for sudo now?
Todd Miller.
He still is. I gotcha.
It's just not
okay.
in the OpenBSD tree anymore.
It's split off.
Yep. So,
Gotcha.
Yeah. So that's pretty much it. Anyone has any questions?
Wait, so we donated once. You and me personally donated once a half a Bitcoin to OpenBSD, and the week after we did that, there was a global fundraiser. I think we inspired them to do it, and then they raised like a few $1 million after that, right?
Maybe.
But
Where's your cut at?
What's that?
Where's your cut?
Yeah, I know. This was a long time ago. I think Bitcoin was worth.
Nearly worth a pizza.
I think Bitcoin was worth about $1,000, and we both donated about $500 to OpenBSD.
Yep.
So,
You need to get your money back.
yeah. Well,
Yeah.
they put it to good use.
Yeah. Yeah. There was another Bitcoin donation that was like double or triple what we did.
Yeah.
And,
But we were the OGs. We did it first.
Yeah. So it's a good little OS. It has kind of a tarnished history. At one point, the install for it was considered to be really, really difficult. This was back when disks spun and you had to partition them by like cylinders and heads and
I think we had a meetup one time a long time ago where we were trying to install OpenBSD with the old partitioning system.
it would have been.
That was fun.
Yeah, it's gone now. So you're doing it with percentages, and you don't have to calculate how many
Sectors.
sectors per sectors per cylinder or anything like that. So, yeah, there's another tarnished history is kind of it has developers have kind of a firm stance on the mailing list side of things. Mailing list is how all the development happens. People email, code changes back and forth, and sometimes some of the developers can get a little short with people, especially people that have
Graybeards being grumpy?
Right.
You don't say.
yeah. Some people incur more wrath than others. Some deserve it, some don't. But it's
How often have you been the focus of wrath?
3 or 4 times. Yeah, but I've
Have
only
you been
broken
the
the tree
provider
once.
of wrath?
What's that?
How often have you been the provider of wrath?
Not that often, really. I've playfully chastised, but never brought the wrath. At least I don't think I have. Probably if I went back and read them, I'd be like, oh god.
You are all idiots. No, that was just friendly.
Yeah, that's just a hello.
Yeah. So
OpenBSD pioneered a lot of the cryptography stuff, right? So not just OpenSSH, they've done, or weren't they? So before LibreSSL, they were upstream for SSL, weren't they? Oh, they never were. Oh, so when they had the problems, then they forked it off and said we're doing it ourselves.
Yeah. Well, so kind of like the history with cryptography and OpenBSD was it's kind of deep. So when the export restrictions and all that kind of jazz was happening.
So this is in the early 90s.
Yeah. Theodorat decided to, and I'm muddy on this, so I'm probably going to tell you wrong, as a joke. So he left South Africa and moved to Canada and propped up the OpenBSD Foundation and stuff there to skirt the U.S. Export restrictions and all that jazz on crypto. And I don't know where things stand today. I know we have a few U.S. developers that work on LibreSSL and other things like that. But OpenBSD was one of the first. I think it was the first open source operating system to ship cryptography and have in its system cryptographic capabilities, and so it kind of pioneered on that front. So
PGP was independently developed, but then it was taken over by GNU. Is that who took it over?
No, I mean the biggest implementation is GNU PG, but yeah, that was Paul Zimmerman, who I met at an ISSA meeting. I'm pretty sure in Springs many years ago.
Oh wow!
I think it was an ISSA. I can't remember.
Oh yeah. Yeah, that's their main headquarters is the Springs chapter. So
So PGP is it's its own thing, but GNU PGP is the most prominent implementation of that. It's also huge. It's a giant code base, which is scary when you have cryptography and all that. So, yeah.
You just gotta trust everybody else's code, right? Yeah.
All 20 million lines of it. Oh my god.
It can't be that one.
No. Yeah. Cool.
So security oriented operating system. So if you really need something to be secure and you're worried about large code bases and lots of surface area for attacks, OpenBSD is what you want to use.
Yep, that's what I use. So my personal critical infrastructure, my DNS servers and things like that, is all OpenBSD. I used to run it on everything, but I have since moved away from that.
I have it running on a Hetzner VPS.
Nice.
Because I have T-Mobile Fiber now, which is a CGNAT network, and I don't get a public IP address. So I use Hetzner's public IP address, and then I have my OpenBSD VM wire guarded back to my OpenSense router,
Nice.
so that I can just tunnel ports out through that
Yep.
connection to a public IP address.
I have the same setup,
Nice.
except not on Hetzner. I've got it on Volter.
Yeah.
So.
Is it cheap?
Yeah, it's like $3 a month or
Oh,
something.
yeah.
So I think that's the IPv6 only one. It's like $4 a month.
That's still not bad. Yeah, I pay like 7 or 8, I think.
Yeah.
But it's way overkill for what I need it for. It's like
Yeah.
6 AMD EPIC cores and
Oh, wow.
16 gigs of RAM.
Yeah. For 8, that's pretty good.
Yeah.
Another possibility that I'm probably going to switch to is using Tailscale and their funnel stuff. So I'm pretty pleased with that.
Yeah, I use Zero Tier for access to my camera system and stuff like that. That I'm not like super concerned with security about.
Yeah.
But
Well, I mean, they still have solid security.
They do.
published code, so.
but I don't get as much control over
Yeah.
it as I do with the OpenBSD VM and WireGuard and filters on my OpenSense box, filters on the OpenBSD
filter.
box.
Oh,
Because
that's
it has PF built
Yeah.
into it,
that's a big feature that I neglected to mention. PF.
which has its own like fork of forks of forks. to
No, that
different
is
projects.
straight OpenBSD.
Well, yeah, but it's used in
Yeah.
OpenSense and PFSense, which are FreeBSD based. Where was that fork kind of in the road of things?
It's a ways back. So the FreeBSD PF fork is they have one major addition that OpenBSD doesn't have, which is full multiprocessing for the PF set. But they don't have all the features that OpenBSD does for it. So once OpenBSD unlocks it, it's going to be way faster.
So is that why the open source security appliances use FreeBSD for?
Partially, probably. I think there's a lot more just availability of stuff compared to OpenBSD too. There's more packages for FreeBSD, kind of stuff like that. Although that might not be the case anymore.
Yeah, I've never tried FreeBSD on its own.
I
Like I
really
have with
don't.
OpenBSD.
I really don't like it. I don't know. I think part of it is because I come from OpenBSD where
Crips and Bloods.
yeah, it's pretty much like that. But like on OpenBSD, everything is consistent, and like there's one tool to configure network interfaces, and it's ifconfig. And like on Linux, you've got IP,
Yeah.
ifconfig, IW.
Yep.
Like it's a laundry list, and it's obnoxious.
As every new version, they've moved it to somewhere different, in
Yeah.
a different YAML file.
Yeah, it's crap. On FreeBSD, it's a little bit better than in Linux land, but there's still a lot of like weird inconsistencies that I can't grapple with. So like there's a difference between running packages from their port system and installing them from a package, and somehow every time I run FreeBSD, I mess that up in some way, and it breaks my system, and I don't know how to fix it, and so I have to like uninstall everything and then reinstall the packages. It's not ideal, and it's not well documented with regard to that difference. So, yeah, I have beef, but yeah, I don't know. NetBSD is in the same boat. It's a little bit inconsistent with regards to things. Oh, the other thing I don't like about FreeBSD is like there's PF, there's IPFW, I think there's 3 firewall implementations on the system, and that seems excessive. So, yeah.
Just means that whenever you look up documentation, there are 2 ones that are wrong before you get right.
Yeah.